Across Australia, the wheels of industry turn 24 hours a day, 7 days a week. These machines are tough, and the teams of people running them are even tougher. But what happens when these massive machines break down?
That's the fun bit.
Teams of Aussie mechanics, engineers, fitters and boilermakers step up to battle against tight deadlines in some of the harshest working environments on the planet.
These are the optimum working conditions.
From deep underground, on the water, on the front line, to high in the sky, they do the vital repair work to keep these heavy metal wonders alive.
Planned out well, it turned out better.
This is Mega Mechanics. This time on Mega Mechanics. A Queensland company, Gilmour Space Technologies, has high hopes of joining the space race.
Essentially, we want to be the FedEx of space delivery.
With millions of dollars at stake, a test run of a prototype engine will determine if they are shooting for the stars or back to the drawing board.
Counting down for a test. Counting down in 3, 2, 1, mark.
There's a lot on the line when a 40-ton tram needs a wheel trim in Adelaide.
I like to check all the jacks at least 3 times before I start lifting because it's quite dangerous if you don't go about it the right way.
It pays to be precise when every cut could cause the whole process to begin again.
Once it's gone, it's gone.
And in Byron Bay, a world-first conversion is causing some headaches.
We're just going to do a brake test to make sure that all the systems are functioning properly.
Packed with new and old technology, this solar-powered heritage train has plenty of challenges.
We've got something funny going on with the drive system.
3, 2, 1, and we have ignition.
Commercial spaceflight, like this Antares rocket launch in the US, is an industry estimated to be worth over $1 trillion by 2040.
When we launch this, it'll be the first hybrid rocket to ever reach orbit.
In terms of developing technology that goes to space and operates in space, we're the pioneer.
Totally unique, and at the end of the day, we're creating history, not only for ourselves, but for Australia.
Tucked away near the theme parks on Queensland's Gold Coast, dedicated engineers and mechanics from Gilmour Space Technologies are racing to test a rocket engine that will help them grab a slice of that lucrative satellite launch market.
This rocket as a vehicle will travel faster than any other vehicle ever made in Australia by many factors.
This will go up to orbital velocities, which is around 8 kilometers a second. Through the atmosphere, it reaches about 6 times the speed of sound.
In the race to build a rocket down under, the team is going where no Aussie company has gone before.
When we started, there was no space agency. You know, the government thought we were crazy. Everybody we talked to thought it was an insane idea.
But their concept is coming closer to reality. Next year, the plan is to start delivering satellites into space from southeast Queensland.
Essentially, we want to be the FedEx of space delivery. There is just not enough supply to fill that demand, and we're looking to make a big impact, not just domestically, but across the world.
In the next 5 years, there'll be about 35,000 satellites get launched into space. So it just dwarfs the amount that are already there, and it is going to be a very, very busy environment up there.
Before it can rocket into the realm of space travel, the team needs to test the technology they've been developing.
Space and rocket technology is really hard. It is rocket science.
Gilmour engineers have designed a hybrid rocket engine that combines solid fuel with liquid oxidizer, a less complex variant than other rocket systems around the world, but one that still promises to deliver high-performance results.
The initial concept of the test today will be a 30-second duration, so we can have the confidence to build and scale up in our attempt to launch by mid-2022.
Because the technology is so new, a prototype has been built out of heavier materials to monitor how the motor performs under stress. It will be transported to an isolated test facility where a crane will place it carefully onto a horizontal cradle. A series of computer-controlled checks need to be carried out before the engine can run for a 30-second trial, delivering vital data to the design team. After months of preparation, the testing should only take a day to complete. With the test run scheduled for tomorrow, Jeff and his mechanical team are assembling the engine for transportation to the test location.
This will be our second test, but a slightly longer duration, and we'll get a lot of data from that, and we can then proceed to fine-tune the finished product.
There's a lot riding on this rocket motor performing well.
This is the main engine that goes on our launch vehicle. This puts out enough thrust to lift about 5 SUVs up into the sky. If you have like a shoebox-sized satellite, that's probably worth about $500,000. And then if you have one as big as like a tall fridge, you know, they can be $100 million. So yeah, you want to make sure you don't crash or anything like that.
With millions of dollars already poured into the development of their Eris orbital rocket, Gilmour Space has asked us to blur some sensitive details. 5 of these engines will be needed to power the rocket into space. The pressure's on to get this project off the ground.
So they get that gasket, so we don't need any blow-ups or mishaps to happen, because they'll just set us back. We just got to keep forging ahead. Welcome to Tramland. Very different world.
Trams are a familiar feature on the streets of Adelaide, South Australia.
We've got a fleet of 24 vehicles. That's 15 Flexity trams and 9 Citadus trams.
So they run for about 20 hours a day, 7 days a week. We need all but 3 trams out during peak service.
Keeping these high-powered electric vehicles on track to avoid any costly shutdowns requires a regular maintenance schedule.
We run a pretty specialised sort of facility here. It's unique. I mean, we do have electricians on site, mechanical fitters on site, and refrigeration technicians. So between us, we maintain the fleet.
Today's job is one of the more detailed. A tram is due to have some work done on its undercarriage.
We bring the trams in every 50,000 kilometres to do a reprofile on the wheel.
To carry out this essential maintenance, the tram will be carefully lined up on a series of jacks and raised. Brakes will be disconnected and a large lathe rolled under to begin trimming the metal. In this precise process, millimetres of wear and tear will be shaved off each wheel to keep them all even. There are 8 sets to service, and once they're all completed, adjustments will be made to the tram's suspension to account for the smaller wheels. It will then be lowered and test run before rejoining service. The team has only 2 days to get the reprofiling done and get the tram back out on the track. Mechanical fitter Sam will be running the show, and his first job is to get the tram lined up for lifting.
We'll just hold it there for a sec. Back about an inch, just if that. Slow as you can. Whoa! Yep, that'll do. That's perfect. If we drive this tram too far, every jack is out, so we have to move every jack about 6 inches. It's just a lot easier if we get them first try.
The tram is in position, but with 600 volts still coursing through the overhead wires, no work can commence until an electrician has isolated the power.
She's off.
The path is now clear for the 40-ton tram to be raised almost 2 metres off the ground, but not before Sam reassures himself that everything's set for an even lift.
I like to check all the jacks at least 3 times before I start lifting, because it's quite dangerous if you don't go about it the right way.
With a multi-million-dollar tram about to become a high flyer,
in my opinion, I'm confident. I reckon we're ready to go.
There's a lot riding on this lift going well.
All right, let's do it.
I usually try and listen out for any sort of strange noises or anything like that. Definitely something that we have to keep a bit more of an eye on for the enjoyment of the customers. The rattly brake shoes being electric because it's so quiet.
Byron Bay, on the northern coast of New South Wales, famous for its stunning beaches and easygoing lifestyle. It's an eco-conscious community where sustainability is in, making it the perfect home for the world's first solar-powered train.
We've got 64 panels on the roof, flexible panels that actually are fitted to the shape of the roof. It generates about 6.5 kilowatts of power on a good day, and using the great sunshine we have in Byron Bay.
Once a month, the Lithgow Railway Workshop sends Ben to do a thorough inspection on this unique train. It's a procedure that starts by riding the rails.
Always looking for something wrong. It's sort of part and parcel of being a fitter.
The main task is a big ask. To carry out a broad range of safety and operation checks on the entire 76-tonne train. The two-carriage heritage train dates back to 1949. These carriages were used on lines all over New South Wales until they were put into storage in Lithgow in 1995. During the restoration and solar conversion process, one of its two diesel engines was removed. In its place, a pair of electric traction motors plus associated equipment, including traction inverters and a lithium-ion battery bank. The solar train is also equipped with a regenerative braking system. Every time the brakes are applied, the traction motors become generators and recharge the batteries. In addition, up to 30 kilowatts of top-up power is generated by an array of solar PV panels on the train's storage shed. The remaining diesel engine is a Cummins 14-litre NT 855. In case of an electrical fault, it acts as a backup, whilst also providing weight and balance to the train. The extensive checklist will see Ben inspect the interior, exterior and undercarriage of the train. He has a day and a half to complete the checks and any repair work required. But there is a hitch.
You can do minor stuff through the day while the train's operating, but most of it's got to be done early morning or late at night. And yeah, it's pretty full on.
In between trips, Ben has a 35-minute window to tick off the smaller jobs, starting in car number 726.
I'm just checking the forward reverse function. I'm just checking the start from this end. That's the backup diesel engine.
He's progressed through to the controls of car number 661, but this train's got a schedule to keep.
We actually do 10 return services a day. Things we've got to look out for is people on the tracks. We've got a road crossing up there with only just stop signs on, and we've got to be very careful with the cars just crossing it that don't stop at the stop signs and aren't used to having a train after not having one for 15 or 16 years. You tend to look at the drivers to see if they're actually looking at you as you come up. If they're not looking at you, you start to get a bit nervous.
Get that gasket. We don't need any blow-ups or mishaps to happen because they'll just set us back. We just got to keep forging ahead.
The mechanical team from Gilmour Space Technologies is preparing a prototype rocket engine for its second round of testing.
Where's the top? I don't think you're going to be able to rotate it.
Every part of the process must be precise to ensure the rocket can handle the forces it will eventually encounter.
Have a look at the other side. A bit of a gap here.
As the mechanics construct the engine casing, the electrical crew has been troubleshooting an issue with the test stand fire suppression system.
So what we've gone and done is put a little interlock here, flick that up, press the button.
Like an arm switch.
Exactly like an arm switch. Looks good.
Upstairs, the Gilmour engineers are on the countdown to tomorrow's engine run. The test should provide vital information to help the rocket fly.
It's pretty exciting because we're going to get some vibration data that then feeds into the structure that we're building at the moment to tell us whether or not it will break or not during ascent.
Back on the workshop floor, the mechanical team has almost completed preparing the engine for transportation.
I reckon we should just keep going.
I tell you what, I keep nipping it up because that's looking freaking awesome. We just do it like evenly. We will test it horizontally on a test fixture. We will then measure the thrust through a load cell to measure temperature, pressure, and this will be a longer test.
Tomorrow will be the moment of truth for the Gilmour Space team.
You need the big torque wrench.
Next day, out at the test facility, lead propulsion engineer David and his team are making sure the support structure is ready for the arrival of the motor.
Rocket engines develop a lot of vibration, and that tends to make bolts, nuts, things come undone. And if it comes loose, it's not going to be a good day for anyone. We're making sure that it's actually ready to go.
It's all calm at the moment, but in the not-so-distant future, this facility will be a hive of activity.
Once we hit the production phase, there's going to be rocket motors and engines coming through this place daily.
It's a lofty aspiration, but for the moment, more down-to-earth problems are threatening the process. The truck carrying the engine is stuck in traffic.
Whoa. You overdid it, Carlos. Too strong.
Leaving some of Australia's most talented technicians with nothing else to do but set up camp as they wait to see if they've still got enough time for today's test.
In my opinion, I'm confident. I reckon we're ready to go. All right, let's do it.
After the painstaking placement of a series of jacks, a 40-ton tram is being lifted for wheel trimming in Adelaide.
It'll stop when it hits that limit of 1.85 metres.
All the prep work appears to be paying off as the tram safely reaches its raised perch.
So just having a quick look at the wheels we've got.
Not surprisingly, after a year of almost continuous use, the wheels are showing signs of wear and tear.
So it hollows throughout the middle because that's just the most common area where it rides. The machine will basically re-profile that to the perfect profile suited to our track, and then it'll be all right for another year.
The more frequent cuts that we do, we just take little skims off the wheel, so hopefully we're taking less material and they can last a little bit longer.
But before the wheel trimming can start, the crew needs to disconnect a vital part of the tram.
A major thing that we got to do is releasing the brakes, because if we don't release the brakes, we're basically doing burnouts. The lathe will spin the wheels, but if you haven't released the brakes, you just basically, smoke will start billowing off of the brake pads and discs, and you'll know about it pretty quickly. But I've done it, we've all done it.
Takes a bit of pressure to get this off. There we go. Gotta use your muscles.
Let's do it.
Let's rock and roll.
With the brakes now released, the crew is ready to bring in the wheel lathe. And there's only the smallest margin for error in its positioning.
Woo, that was close.
The amount of room that we're playing with is very, very minimal. We're very compact, and that's what the white line's for. We just make sure that the jacks are behind that white line. If they're not, we could smash the lathe into the jacks and, yeah, cause some issues.
Now it's just a matter of making sure the lathe is placed perfectly to cut.
All right, so I'm happy with that. If you look at there, it's bang on central with the wheel.
From here, the machine takes over, with a little help from the humans.
We're at the A end of 114 tram, axle 1 of 8 axles. So just basically telling the lathe what we're doing.
With 2 wheels being cut at the same time, the automated process takes all the guesswork out of calculations.
The lathe's measured up the wheels. It's basically told us for the variant that we want, we've got to take 10 millimetres off of the diameter of the wheel. So we're going from 559 to 548. That looks a bit better.
Yeah, that's all right.
Yeah, all right, we'll go with that. All right, let's go.
It's taken half a day just to set up for the first cut. And with this tram required back in service by the end of tomorrow, just one wrong move could cost them valuable time.
If you have any form of stuff-ups, you basically need to start again.
Yeah, we've had a few close calls, a few of the drivers had. Yeah, I've had one or two myself.
In Byron Bay, for the first time in 15 years, there's a train to watch out for. A world first. A restored two-car heritage train that's been converted to solar power.
They're just not used to seeing a train here after not having a train for so long. And today they're all playing the game very nicely and it looks like they're going to stop at the stop signs.
Along for the ride is Ben, a fitter from the Lithgow Railway Workshop, who's here to carry out the exhaustive monthly inspection.
Another great trip, yep.
And the last for the day. After doing minor jobs in between trips, Ben now has until tomorrow morning to get through a massive checklist.
Righto, so we're just gonna start the engine up and do a stall test and get everything nice and warm so we can check for leaks. This is your brake cylinder here, which activates the brakes on this bogie. So the whole train in electric drive mode is powered by these two Parker electric drive motors into this gearbox. It's pretty amazing, the size of those two electric motors for driving this whole thing.
Should they fail, one of the original engines serves as backup.
So this is the diesel engine, the same as a bus or a truck or a car. So engine, transmission, drive shaft, differential. Here we've got the smoke and fire alarms up there, so we actually set those off to test them and make sure that they work. A couple of different sensors under here, so that one detects flame. There's another one under there that detects smoke. So it flashes red, which is picking it up, but it's not quite enough to trip out the alarm, which is good that it's picking that up.
It's a job that requires mechanical expertise and contortionist skills.
So you can see there's some residue of coolant on that flange. No current drips or anything like that, so we'll clean it up and we'll keep an eye on it for next time. I've got a service sheet that I tick off everything as I go. Just some grease into the uni joints. There's 4 little bearings in each one of these joints, so we just want to purge all the old dirty grease out and make sure that we've got nice new fresh grease. The service sheet's there as a double check to make sure that I've done it all right and haven't missed anything.
Being meticulous is vital.
People ride on this train every day, so basically the safety of all those people is effectively in my hands to make sure that I inspect everything and make sure that it's safe to go, and I definitely treat it like that.
I think we're, at least an hour to 2 hours behind schedule already, because can't control the traffic. We can build a rocket, we can't control traffic.
The long-awaited engine has turned up at the testing facility in southeast Queensland. And thankfully, it's still all systems go for today's test.
This is what's deemed a boilerplate motor. So typically with a lot of rocket motors, they'll be designed with very heavy or thick-walled materials to begin to withstand a lot of the vibrations during testing, to understand the internal characteristics. While it is big and heavy, it's still quite fragile. During transport, things can shake loose. So once we get on the stand, we'll do a full check out of the whole system.
This heavy prototype will eventually be scaled back to a more flight-ready design, but not until the extensive testing is complete.
All right, touch more. Yeah, it's perfect, mate.
Essentially, we're just trying to align the motor with the crane over to the test cell as quickly as possible. Obviously, the motor weighs many tons, so putting it on the support structure isn't an easy job, but we also trying to want to make it safe as possible and make life as easy for us as we can.
other way. The other down. Okay.
But the truck's not as happy as it was. So we're putting it on the ground and getting the truck into a better position to have another go.
Second time round, and the lift looks more promising.
That's good. Straighten her up. It's not quite square, you gotta push your end, Jeff. Yeah, that way, your end. That's square.
The rocket engine isn't landing without incident.
Yeah, there's a fitting on the front of the motor that's about 5 or...
And that's what interferes when it's on the cradle?
Yeah.
All right. Put a glove over it. Yeah, get it off. Get a glove.
A sensitive piece of the equipment needs handling with more than kid gloves. The rubber variety is added for padding. Even with the extra protection in place, the team decides to maneuver the motor into position with manpower.
If you put your foot on the block and push on the flange.
If you have any form of stuff-ups, you basically need to start again.
After half a day of preparing, Sam and his team are anxious to see how the trim on the first set of tram wheels turns out.
All right, let's just pray that it's...
You're gonna be good, mate. This is winning. You got this.
I reckon.
Oh, yeah. Yeah, that was a sexy cut.
The first cut is never the deepest. Small increments are gradually scraped away to avoid costly mistakes.
Once it's gone, it's gone. And it's quite frustrating when you've taken off too much because you just have to keep chasing your tail, slowly trying to make it, just adjusting it.
So far, the signs are looking promising that the lathe is performing well.
The machine will stop in a minute and it'll do another measurement and it'll show us where we're at and if there's anything that we want to adjust before we do the last cut.
So go through and spit out some numbers and hopefully they're within the tolerance. What's the tolerance, Sam?
0.25 of a millimetre across the whole bogey set.
With such fine margins between desirable and disaster, success is determined by complex calculations.
So we're all good. So the difference in diameter between these wheels are 0.03 of a millimetre. So
that's really good.
Absolutely nothing, basically.
Yeah, nothing. I'm taking responsibility for that. I think, you know, it worked well.
That's right, yeah. That's right. On another note.
So it looked like a good cut, so it went well.
But with only a day and a half left to get the job done, there's no time to celebrate their success.
We unclamp and go to the next one.
The lathe needs to be repositioned for the second set of wheels on the bogie. But before that can happen, the support structure has to be streamlined.
One major thing that we must remember to do is put these blocks in, because if you don't, you'll drive the lathe right into these jacks.
The crew still has 7 axles to go, so every step needs to be carefully checked to avoid destroying the progress they've made.
Starting on the second one, but if they're not within 0.25 of a millimetre of the first wheel set that we machined, then we have to start again, go back to the first wheel set and remachine the whole bogie again.
People ride on this train every day, so basically the safety of all those people is effectively in my hands.
While Byron Bay sleeps, Ben, a fitter from Lithgow Railway Workshop, is busy inspecting the belly of this unique solar-powered beast.
There's a few minor little things to take note of. Yeah, we've managed to get through a fair bit tonight, and yeah, we'll continue on in the morning.
With the sun up, Ben's got to stay on track in order to complete the monthly inspection on the solar train before its first run at 10 a.m.
We're just going to do a brake test to make sure that all the systems are functioning properly, and the train will be right to go out this morning. We'll apply the brakes and make sure that we've got good pressure in our straight air pipe and our brake cylinder. The final check we need to do is something emergency, so if something goes wrong and we need to stop the train really fast, the driver will reach down and pull his handle, which dumps all the pressure out of the brakes and fully charges and locks the brakes on.
Today's driver, Mick, is on hand to help with the tests.
When we're going through testing the brakes apply and release, we're testing that cylinder is fully actuating backwards and forwards, and the brakes are applying when we have an emergency or something like that. How'd that go, Mick? All good?
Good, mate, all good.
Oh, very good.
One job is to check on a coolant leak.
So we just had a little bit of an old coolant leak. We tightened the bolts up on it last time I was up here, but it looks like it hasn't progressed, so we've just scraped off any of the residue and that sort of thing, so that next time we have a look at it, we'll be able to tell easily if it's kept leaking.
Just when everything seems to be going according to plan, and with only 30 minutes until the first departure of the day, Ben discovers a problem.
So we've got something funny going on the drive system. We'll do a bit of a reset and see if it all clears itself. We've probably got about 20 minutes left, I'd say.
If you put your foot on the block and push on the flange.
A rocket engine has been testing the team from Gilmour Space Technologies before it's even up and running.
1,
2, 3.
Yeah.
Lube is all you need.
Yeah.
All right, can we jack it from there? Have we got thread?
Yeah.
Let's just jack it in.
Yeah.
Let's get the bolts in and start jacking it in.
Once the heavy prototype is secured into position, the team of technicians can begin prepping it for its second test run in as many months.
Our first test was really promising results. As we get longer durations, we're going to learn plenty more, and we're probably going to get a few surprises as well along the way.
While the team ready the engine for the test, David takes up his position in the on-site control room, where he can monitor the preparations.
TC Delta PT Kilo, 4 dome pressure transducer is called and check.
Copy, thank you. You can do the aft dome next.
We want to go through the sensors methodically, make sure everything's working, they're reading correctly, so that we get all the data that we need. Because the whole point we test is we want to gather data to improve our design.
During the 30-second engine run, the team will be measuring temperature, pressure, acceleration, and G-force.
Reading 510 kPa.
Copy, we'll pause for a moment. I'm reading similar. Allow it to stabilise. If you guys could now stand clear of the test article, I will apply purge pressure to the motor.
Okay, you guys want to stand clear for a mo? Standing clear.
Okay, opening the motor purge and reading purge pressure, which is rising.
So at the moment we're putting a small amount of pressure into the motor, the idea being that we want to check to see if there are any leaks before we do the test.
So far, everything appears to be performing as expected.
Okay, system is disarmed. You are cleared to approach and inspect the leak.
Approaching.
Some of the methods employed to check this high-tech setup are surprisingly low-tech.
We're using a mixture of essentially soap and water. We're spraying it on all the connection points. And if we do have a leak, it'll bubble and it'll be very clearly visible where the leak is.
But Carl may have spoken too soon.
I appear to have also a fair leak in the motor now. The pressure is steadily falling.
Oh, okay.
David has detected a problem with the pressure in the engine.
So I am seeing approximately 5 to 10 kPa
58 per minute. TC Delta, no visible external leaks detected. We're going to keep looking though.
A fall in pressure could be a significant problem for today's test. The team needs to urgently pinpoint the cause if the engine run is to proceed as planned.
We're starting on the second one, but if they're not within 0.25 of a millimetre of the first wheel set that we machined, then we have to start again, go back to the first wheel set and remachine the whole bogie again.
The team trimming at Tram's wheels in Adelaide is trying to avoid any backward steps as it works its way along the undercarriage. There's ample evidence the lathe is making inroads.
Over the whole tram, we could fill up a whole bin full of this.
The long, curly shavings are known as swarfs.
Sometimes the swarf comes flying out and you almost need to dodge it.
But the metal offcuts can be more than just an airborne distraction.
So if you don't grab the swarf, the rollers that have so much clamping force, the swarf gets wedged between that and the wheel, and it just makes a massive dent in the brand new profile that you've just cut into the wheel. And then sometimes it's that bad that you need to go over it again because you've basically just chipped the profile of the wheel out from how thick the swarf can be.
So far, the crew has managed to avoid any damage.
We're on the right track.
But they're going nowhere fast thanks to the precise nature of this job.
So, axle 3, LD1, we are ready.
Are they nice flight carts, are they?
Yeah, they're about 1.4, I think. 1.6. The next one's going to be 2 mils, so it'll be big, all right?
It's a tedious, time-consuming process, and small victories are a cause for excitement.
Oh, what do we got? Look at that. These wheels, they are exactly the same size as each other. Within 0.003, under 0.01 of a millimetre in difference of diameter. So the lathe's working exactly how we want at the moment. It's doing what we want to do.
But at the end of a long day, and with only 2 axles left to do, Sam may have got ahead of himself.
Oh no, cut it.
Right, so we've got something funny going on the drive system, so we'll do a bit of a reset and see if it all clears itself.
In Byron Bay, Ben from Lithgow Railway Workshop has discovered a problem with the drive system. With only 20 minutes before the next departure, he has to work fast to rectify the problem.
So you have to turn off all the isolators and power. We need to get this sorted out before the train's got to go. Worst case, we can run it on the backup diesel engine if need be, but we'll go through and do a reset and hopefully everything sorts itself out. Yeah, here we go. So the whole train's trying to lurch forward to take off, which is exactly what we wanted. So we went through and reset everything, and then the battery management systems, and it's gotten rid of our drive fault.
The exterior also needs some attention.
So I've had a couple of rivets let go out of the panel here, so we're just going to drill them out and replace them with some new ones.
While Ben pops in the rivets, Mick tops up the train's batteries. In addition to the train's solar panels, the ones on the shed roof are capable of producing 30 kilowatts. On a sunny day, the excess power fed back into the grid is enough to supply 17 houses.
People coming on, we usually have a fair few passengers throughout the day, so it's a fairly busy little operation. It doesn't stop. So we've just done the first trip of the day after we worked on it this morning. We're just listening out for any sort of unusual sounds or anything like that, or any signs of anything that's, that possibly may need our attention.
It leaves one last easy job to tick off.
Righto, so we've got a brand new air filter for the air compressor. When we had a look at it before, it's pretty dirty, so we'll just quickly jump under and change that out. So we've just finished up here doing the service on the solar train. We've been through all our checks and inspections and everything's gone really, really well. So we're done and dusted. Time to get out of here.
Appear to have also a fair leak in the motor now. The pressure is steadily falling.
Oh, okay.
A planned test run of a rocket engine might need to be delayed after computer diagnostics identified a leak.
TC Delta, no visible external leaks detected. We're going to keep looking though.
But with no obvious problems around the engine itself, the team of technicians is now checking the gas supply in the hope of identifying the cause.
It might just be the gauge on the regulator. I just opened the valve. It's still quite significant. It was ear piercing when I opened it.
All right, great. So then I'm happy to reconnect to it and we'll move on.
With everything back on track for the test run, the final step is to monitor the liquid oxidizer being added to the hybrid engine.
Now we're just getting suited up into our PPE for handling the oxidizer. It's not very nice for humans, but great for rocket fuel. So at the moment we'll just get up, gear up so that we can fill the tank safely without hurting anyone. TC Delta, PT Kilo, comms check in PPE.
Loud and clear.
Copy, I will be relaying and Jeff will be entering the container.
Copy, understood.
Approaching container, let's go around the back, Jeff.
Every precaution is taken when handling any part of the rocket's fuel supply.
Okay, Patex fill target has been reached. Okay guys, you are clear to approach the test stand. The first action will be to close the oxidizer fill manual ISO valve at one of the base of the tank. Can you please close the manhole lid on the HP storage tank? All the sensors checked out, so I'm happy with the feedback.
It's now all systems go for the test fire, and the big guns have turned up to watch.
Today we're testing and verifying our main engine, which is another significant step for us, so we can have the confidence to build and scale up in our attempt to launch by mid-2022.
I'm not unhappy with a single bottle option as well. Tank is pressed, flipping the preheat valve. Good decomposition. Counting down for test. Counting down in 3, 2, 1, mark.
Disarm the control system. Open the motor purge valve, GMPV 201 for 10 seconds.
Test completed successfully. Venting the tank down. Remain where you are.
After years of planning, months of fine-tuning, and days of preparing, the rocket engine has proven it's up to the task.
Well done, mate. Good work. Good work, guys.
Oh, very happy. It's always a good day when you get to fire a rocket motor.
Fantastic test. We ran to duration, everything live, observed, looked nominal, so we're stoked. It was really great result. Looking forward to the next one.
Oh no, cut it.
Flying sparks have halted a tram wheel trim in Adelaide.
Sparks and things like that are indicators that it's time to change the tips over.
The cutting tool of the lathe is showing the strain of working its way through 6 sets of wheels.
So that's definitely burnt out on the top there, so you can see that these wheels must be quite hard and this till bit's definitely needing changing.
Fortunately, it's an easy fix and the lathe is up and running again quickly.
There we go. You can see already the cuts already cutting much smoother, no sparks. The finish looks a lot nicer, and yeah.
The crew decides to quit while it's ahead, leaving the wheels on the last bogey for tomorrow.
I don't want to be risky. I had the feed rate on quite fast. I don't want unnecessary stuff-ups here today.
It's day 2 of wheel trimming on the tram, and the team is hoping to have the job finished before the evening.
Let's go to the last bogey. 3 out of 4 done.
It's all looking hopeful to finish on time.
Oh. Fucking hell. I went down my shirt.
As long as random flying swarf doesn't derail the schedule.
I think it burnt my chest hair a little bit. I can smell that burnt human smell.
Sam might be feeling the heat, but he's managed to complete the reprofiling of the 8 sets of wheels. And the job isn't over yet.
So we shim the bogies. So we pack a series of 10mm shims or 5mm shims. Depending on how much you've cut off, you pack these springs that actually brings the height of the tram up. So we've dropped the whole tram, but you use these shims and it pushes it back up again.
It sounds fairly straightforward, but when it comes to the crunch, the packing process can prove challenging.
Well, I've told the supervisor I have it done by the end of the day, so better get a wriggle on.
It takes Sam several hours to shunt all the shims in.
Bang. That's in, they're all in.
A few minor adjustments are still needed, but the tram is close to being ready to run. With power and brakes now reconnected, it's left to Sam to take the tram for a test run.
Okay, here we go. Yeah, all good, feels pretty smooth. I'm happy, tram can go back into service.